Coming to character functions, let's begin with ASCII function, which returns the decimal representation of the first character from character data. Let's look at some examples. Select ASCII of A from dual. We get the value 65. We can also specify ABC, still we get the ASCII value of the first character. We can change this to small case. We get the ASCII of the small case, or small letter A. Next function is CHR function, which is opposite of the ASCII function, which returns the character based on the number code. Select CHR of, let's say, 65 from dual. We get the capital A, and now if we give 97, we get the output as small a. Next function is concat, which concatenates two strings. Using concat function, we can concatenate two strings. Let's look at the example. William Turner from dual. Now these two strings are concatenated into a single string. We can also use pipe symbol to concatenate. Since the concat function have the limitation that it can take only two strings, we have the pipe symbol using which we can concatenate more than two strings. From dual, we can specify some space in each of the string, and then it works for the readability. Here we can see using pipe symbol we can concatenate more than two strings. So using the concat function, we can only concat two strings, whereas using pipe symbol we can concatenate more than two strings. Next function is instr, which is which returns the position of a substring within a string. Let's see an example. Select instr. Let's give a sentence. Now, if you look at the example here, we can see the letter E is placed. The position of the letter E is sixth position in this word, in a sentence. So instr gives the position of the substring that is specified in the function. It actually contains two more parameters. By default, they both will be 1 if we do not specify the parameters. Let's see. Let's add more parameters and see the example. Let me see. Say 1, 1, where the third parameter 1 is the position where to start the search, and second parameter is the occurrence that we are looking for. So when you say 1, 1, what it means is the search will be started from the position 1, and also the occurrence we are looking for is first occurrence. When we specify 1, it means we are looking at the first occurrence of the letter E. If you run this query, we get the same result 6. Now let me change the occurrence to 2 and see the result. If you look at the result, it is 13, which is nothing but the second occurrence, and we have the second occurrence at in the THED. So this is the second occurrence we are looking at. We are looking for second occurrence, and then the position of the second occurrence starting from the first position. So if you look at this, these are 6, and then we have a characters space 7 and 8, 9, and then 10, 11, 12, 13. So 13 is the position of the second occurrence of the letter E. We can change the position, the start position also. So we can say, for example, let me say it as 7, and now you can see uh, from 7th position, which is this position, we are looking for the letter E, and we are looking for the second occurrence. So we have the first occurrence at the position here, so which is nothing but the 3, 4, 7, and then we have the second occurrence here, which is nothing but the 16th position from the beginning. So the position the position that is displayed will always be counted from the start, whereas we can specify from where to start in the third parameter. So search, we are looking for the letter E from 7th position, whereas when the output will be displayed displayed with the count starting from the first position. We can also specify negative if we want to search. We can also specify the negative number in the third parameter. Then the search starts from the last position. For example, in this example, we can just say -3 and then 1. Now, if you look at the data here, we are starting from this position, and then so the position will always be displayed with respect to the start of the uh, sentence, whereas the count will vary based on the positive or negative number. For example, here we are saying -8, and it looks from -8 character, which is starting from the end, and so it will be 1, 2, 3, 4, 5, 6, 7, 8, and this is the -8 character starting from here. Uh, the function is looking for E, uh, and the occurrence is first, which is nothing but this position, which is the position number 6. Let's look at the next function, initCap, which converts the initial letter of each word in the the function to capital letter. Let's look at an example. Select initCap. We have given all small letters, and now you can see it is initCap. You can see the letter O is it has been converted to capital letter. We can also use multiple words and then see. Now you can see the initial letter in each of the word is converted to capital letter. So initCap converts first letter in each of the word given in the function to capital letter. Next function, let's look at length function, which retrieves the length of the character. So this function returns the length of the character, how many characters are available in the given value in the function. Now it gives you 10, length as 10. So this is basically used to provide the length of the specified string. Next function, lower, which converts all letters that are specified in the string to lowercase. So if you have characters in the string which are not not letters, then they are not affected. Let's look at some example. You can see this the Oracle which was given in caps has been converted to small case. So if we give number data type, so along with the character, it will not be affected, it will remain the same. Now next function is upper, which is opposite of lower, which converts the uh, lowercase to uppercase. So you can see all the letters have been converted to uppercase. Next function is ltrim function, which removes all the specified characters from the left hand side of a string. So this gives the same result set. Now let's add some space to this on the left hand side and see the result. Now you can see the space on the left hand side have been deleted using ltrim function. We can also delete uh, some the characters from the string. Let's see that example. So this should be given in quotes. You can see we have specified O as a second parameter, and then you can see O has been removed from this string. So we can also specify multiple words. Now you can see OR has been removed from Oracle using ltrim function. As specified, I have given input as OR and then Oracle. So both have been removed since we have given ltrim function. So we are trimming OR from the string, and then if it is repeated multiple times without break, then even that the multiple OR values will be removed. And if you have something at the end that will retain, it will not be removed. So if it is present in sequence, then only it will be removed. So we can also specify number here. Number is considered as string here, and I'm removing the number 12, and then you can see 12 and 1 2 1 2 has been repeated, and then they both are removed from the result set. The values are removed if they are part of the second parameter, uh, even though they are not in sequence. Let's see one example. Ltrim of, let's say xyz. Now you can see xyz is in sequence here, where we have mentioned in the second parameter, whereas the second part, they're not in sequence, but still the values are removed. So they need not be in sequence, but they have to be part of the combination. For example, if I specify something, some other value after xyz, let's say p, so you can see the rest of the values are not deleted. But whereas in the previous case, you can see all x, y, and z values are removed from the string. Next function is lpad, or let's look at ltrim rtrim function first, so that it will be easier to understand. So rtrim function works similar to ltrim, whereas in ltrim we are removing the values from the left hand side, whereas in rtrim we can remove the characters that are specified from the right hand side. And if no characters are specified, the the blank spaces or null values are are removed. So rtrim of, so I'm first example, I'm not specifying any string there, and you can see the value Oracle is displayed, and the spaces are have been removed uh, from the string. To see if the spaces are really removed, we can use the length function. Select length of Oracle with spaces from DL. You can see it's giving length as 9, whereas when we use the rtrim function, let's see the length. Now you can see length is 6, and 3 space characters have been deleted. So this is similar to ltrim. So we can let's look at some more examples. So we can specify a space character uh, to be removed. You can see only Oracle is displayed now. So we can also uh, specify the character. Let's say E. You can see E has been removed from the output. Also the same example that we have looked at previously. So we can specify the same example here. You can see all the x, y, z values are removed, though they are not in sequence. Whatever we have specified, all of them have been removed. You can see only Oracle is displayed. So this works same as LTrim, except the fact that the removal of the characters from the string happens on the right hand side. Related to trim, we have one more function called as trim, which is, you can say, combination of ltrim and rtrim. So trim function basically removes all the characters either from the beginning or the end of the string. So let's look at example. Here we did not specify anything, and you can see all the characters from the beginning and from the end have been removed. So we can specify the character also. So here we have to specify the character O from. Now you can see the result set. The O has been removed from the both ends of the string. So we can specify the character, and then the character is removed from both the ends. We can also remove the leading or trailing values using the trim function. Let's see one example for each. From dual. Now you can see all the zeros have been removed from the start, and we can also give it as trailing. Here we can see all the values from the end have been removed, whereas the initial values are retained. And we can also mention both a keyword which will remove values from both the ends. So instead of leading or trailing, we can specify both. Here you can see all the zeros have been removed from both ends. So since we have specified 0 and both, we can see the value as 1, 2, 3. Now let's look at the lpad function, which pads the left hand side of the value of the string with a specified set of characters. And when you do not specify any the character set, spaces are padded on the left hand side. Let's look at the example. Let's say lpad and give the value as 10. Here you can see uh, the string Oracle is of 6 characters, and then we have given the padded length as 10. So the 4 characters of space characters have been added at the beginning of the string. And we can also specify value lesser than the length of the string, and you can see the result. If I say, let's say 4, you can see only 4 characters are displayed. So 2 characters are missing. Now, if I want to specify some value, let's see how the query works. Let me say 10, and then I say Z. Now you can see the initial 4 values have been replaced as Z. So this has become length. The length has become 10, and wherever the string does not have a value, Z is included. So RPAD works in the similar fashion, but yeah, difference being the on the right hand side the changes takes place. Let's look at the example. Now you can see the 4 characters have been added at the end, and if we are let's repeat the same example here. So LPAD, I'm making it as RPAD. Now you can see Z have been placed in 4 places after the string Oracle. Let's look at the replace function, which replaces a sequence of characters in a string with another set of characters. Let me clear screen. Let's look at some example of the replace function. Select replace. Here I'm not giving any function, any value to replace the string 123. So you can see it has been removed from the uh, string 123 has been removed. Now if I give some value with which this value has to be replaced, let's see the result. Now you can see 123 has been replaced with 999 that we have specified in the function. Next function is substring, substr, which allows you to extract a substring from a string. Let's look at the example. Substr, and then so I'm starting the next parameter is the position from which we have to from where we have to extract the data, and then the next parameter is the length of the string that we have to extract. If you look at the output, you can see uh, we have specified one, which is from the start of the string, and then we have specified 2 characters have to be retrieved, and we can see OR has been the output. We can change this position, and let's look at one example. So I can say some 7 character start at 7th character, and then extract pull out 2 characters from position 7. Now you can see these are 6 characters, and then we are starting from 7, and then 8 2 characters we are retrieving. You can see space and O. Similarly, we can also specify the start position as a negative number. When we specify negative position, the count will be started from the backwards. For example, if I say -7, let's look at the data now. So you can see from the back, this is 3 position, and then 4, 5, 6, and 7. This is seventh position, and then two characters th. So we have retrieved the characters t and h. Let's look at the decode function, which is nothing but if then else statement. Uh, let's look at different jobs in EMP table. Now let's look at decode example. Decode of job. If the job is clerk, I want to give the grade as 1. If the job is salesman, I would like to provide grade as grade 2, and then the final value, the default value, grade 3 for the rest of the jobs. Let's also look at the job value. If you run this query, you can see the result now. Let us sort based on the job. You can see all the all this clerk have been given as grade 1, and then we have the salesman. Okay, we have given grade 3 for both, so we'll just modify the query. So you can see all the salesmen have been given as given the grade as grade 2, and for the rest, manager and analyst and president, they are given as grade 3, which is nothing but the default value that we have specified. So whenever the job is clerk, grade 1 is displayed, and if the job is salesman, grade 2 is displayed, and for the rest it is grade 3. So this works as a if then else statement. Let's look at the coalesce function, which returns the first not null value. Let's look at the data in the EMP table. Now the coalesce function returns the first not null value. Let's say if I say commission and then manager, employee number, you can see let's display all the values as well. Now you can see we are displaying commission value first. If it is null, then display the manager. If it is null, then display the employee number. So you can see the commission is null here, and hence it's looking for the manager, which is 7902, and since manager is present, 7902 is displayed here. For these two values, we have the values are not null, and hence same values are displayed, whereas here the fourth record, commission, is null. Then it's looking for the manager, and since manager is available, uh, we can see the manager value. Similarly for other cases, whereas if you look at the this case where commission is null and manager is also null, and in that case it is displaying the employee number 7839. So you can see 7839 has been displayed. So this is how coalesce function works. It displays the first not null value from the list of expressions that we have provided in the function. Then there is nullif function, which returns the null value if both the expressions provided in the function are equal, else it displays the first value. So I'm giving the values as same. You can say null is displayed. When I'm making the values as different, the first value is displayed. So this is how null if function works. So whenever the values match, it displays the same value, whereas whenever the values are different, it displays the first value. So here values are matching, and then it displays the first value, and then I'm modifying the first value. You can see it displays the first string. And we have NVL function, another function which handles the null. All of these functions actually handle null values, and here we have one more function called as NVL, which displays the it replaces a string value if it is null, if it will be replaced. So let's look at some example. So here we have given null value here in quotes without space. So it's a null value, and we are null is displayed since uh, the first parameter is null. If the first parameter is not null, it will be displayed as is. You can see ORCL is displayed since this is not null. So NVL function works this way. Whenever there is a null value, we can replace that null value with some string or number if you are using number data type. So you can say the number has been replaced. If we are the first parameter is not null, the same value will be displayed. Now coming to aggregate, these functions are single row functions that we have seen till now. There are another set of functions which are nothing but the aggregate function, and these functions, aggregate functions, are group functions. We can call them as group functions as well. They are built-in SQL functions that operate on groups of rows, and the return is uh, they return single value for the entire group. We have functions such as count, average, sum, distinct. So these are the we also have some more such as max, min. These are the values that. So these are the aggregate functions that return a single value when they are applied to a group of rows. For example, we can find the number of records that are available uh, in a table using count. Select count star from EMP. Star means we can also specify star is like all columns, and we can also specify a particular column. So this function ignores the duplicate values. For example, we can look at the department number. You can see the count as 14, whereas if you look at the department number in EMP table, it's only 3 values, and they are repeated like 10, 20, and then 10. We have 10, 20, and 30. So all the aggregate functions except count star ignore null values. Let's look at one more function, max function. Select max of sal from EMP. Let's look at distinct sal in EMP table. Order by sal in descending order. So here you can see the maximum salary that is available in EMP table is 5,000, and using max function we could retrieve the uh, the maximum salary. We can also use min function, which is opposite of max, and which retrieves the minimum salary. So here you can see 800 is retrieved. You can also use these functions on the columns that have null values. Null values are ignored. Uh, you can say commission from EMP. Here we got 1400. Let's look at distinct commission. Here we have 4 commission, whereas the number of records in EMP table is 15. So null values are ignored, and we got the result. So here we can conclude null values are ignored by the group functions except count star. So we also have one more group function called as average, which is the gets the average value of a numeric column. For example, select average of sal from EMP. So we got the value 2073.21429. So this the average is derived by sum of the total salary by and then it is divided by the number of salaries in the employee table, which is 14. So we can have a look at it divided by 14 from EMP. So we can see we got the same result set, which is 2073.21429. So we have the same result, which is derived using the average function. Now coming to group by clause, there is a clause called as group by, which is used with the group functions to retrieve data, and we can group the data according to one or more columns from the table. For example, let's look at EMP table once again, and here we have there are different departments 10, 20, and 30, and we have different salaries. Now I want to see the sum of salaries as per the departments. So how to do that? That using aggregate function sum, we can see the sum of total salary that is available in the table. But I want to look at the sum of the salary department wise. That can be handled using group by function. Select department number and then sum of sal from EMP table, group by department number. So here you can see the aggregated the sum of the total sum of the salary department wise, we can see. So this is done by using group by clause, and then specifying the column which by which we want to look at the data. We can also look at the sum of salary based on the job as well. So now if job wise aggregated data, we can see, like for a clerk it is 4150, and then salesman, president, and analyst. So this we can use all the group functions using group by clause, and then look at the data based on the uh, column that we are specifying. Let's for example, we can see count of sal, and then here you can see count of this salary column based on the job. So for or we can specify employee number. So count of employee numbers who are working as different who are having different designation. So here we can see clerk. There are 4 clerks and 4 salesmen. Then you have 1 president and 2 managers, 3 managers, and 1 analyst. We can also use multiple group functions. Here I can say sum of sal as well. So here you can see we have multiple group functions in a single query. So for clerk we have the total aggregated value as 4150, which we have retrieved in the previous query. We can also use group. We can also look at the aggregated data based on multiple columns as well. Let's see how can we do that. So I can use department number and job wise the salary, aggregated salary, and then we have to specify in the group by clause both the columns that we have specified in the select clause. Now you can see. Let me sort by department number so that it will be easier. Now you can see in department number 10, and then you have clerk, manager, and president, and then the salary is aggregated. Similarly, department number 20 and then 30. So we have done the aggregation based on the department number and job. Now one one point to remember here is that whatever column that we specify in the select clause have to be specified in the group by, else the query will give an error. For example, if I remove department number from here, you can see an error which says not a group by expression, and a star is present here under the column name that is not included in the group by clause. So it is mandatory to mention the column that has been that is available in the select clause in the you have to mention it in the group by clause as well. Also we can do a group by we can mention column that is not available in the select clause in the group by clause. That case it works, but data may not be appropriate, and I mean the it's not readable, I can say. For example, I'm grouping by both job and department number. You can see I'm displaying only job, whereas I'm doing a group by job and department number. So if you see the data, right, it says manager, and here again manager, and here manager, and there are 3 records with manager, and yeah, you can see the data that is available, right, it's not proper readable format. So it is always advisable to include in the select clause whatever columns that we are using in the group by clause. There's one more clause called as having clause, which is used to have a to add one more restriction on top of the group function. So if we want to restrict aggregated result using some condition, we can use the having clause. Let's see an example. Here we have job and then department number. We can see the data that is available. So let me sort the data. Now you can see department number 10, and then under 10 we have different jobs, and then the aggregation is done for the salary. Now I want to add one more condition on top of it, saying I want to display only a data that is where the aggregation is more than 2000, or let's say 3000. So that we can do uh, using having clause. Let's say 3000. Now you can see only the value that where the sum is more than 3000 is displayed. So we have the having clause, which helps in adding extra condition on top of the grouping. So when you do a group by and you want to add more condition, we have a having clause. So the values that are less than or equal to 3000 are not displayed in this output. You can see there are only 3 records which are more than 3000. The where clause and having clause have some differences, though they both are used to apply extra condition. So in the where clause, right, when you in the where clause, it specifies a criteria which individual records must be for the data to be retrieved. Whereas the having clause, it cannot be used without the group by clause, and where clause can be used without the group by clause. And the where clause, right, it selects rows before grouping, whereas having clause select rows after grouping. So these are the major differences between having and where clause. Let's end this session now. Thank you.